Hi everyone, and today I'm here with some questions on equation of a straight line. So first we will recall that what are straight lines, and then we'll look into the concept of parallel and perpendicular lines, and we'll be finding their equation as well. So let's begin. First of all, we have the general equation, that is y is equals to mx plus c. And when we talk about this general equation, here y and x are the coordinates or any coordinate present on a straight line, and this m is the gradient which is multiplied by x, and the constant number given in an equation is y-intercept, and y-intercept means that the line where the line cuts the y-axis. So this is the general equation, and this is necessary that y is alone and y has a constant number of 1 plus 1. This is necessary to be done when we compare it with the general equation. So here we have an example of y is equals to 3x plus 6, where 3 is the gradient as it is multiplying by x. It is shown up here, and here the constant number is 6, which is c. So y-intercept is c, or y-intercept is c, or c is equals to 6. Now we'll look into a question. I have a question that find the gradient of a line which is parallel to y is equals to 8x plus 5. So I have an equation here, and I need to find the gradient of the line parallel to this line. So when I compare this y is equals to 8x plus 5 with y is equals to mx plus c, so this is my m, 8 is my m. And when I talk about the parallel lines, so parallel lines have the same gradient. That means that this line has a gradient of 8, and the other line parallel to it will also have a gradient of 8. So I can say that the first gradient would be equals to 8, and the other one I have a gradient of minus 1 over 2, which is multiplying by x. So the when I talk about the parallel line, it will also have a gradient of minus 1 upon 2, as parallel lines have the same gradient, as m1 is equals to m2. Whereas when we talk about the perpendicular lines, if I want to calculate the gradient of a perpendicular line, here this line has a gradient of 3, and when I talk about a perpendicular line's gradient, I keep in mind that in perpendicular line the gradient are negative reciprocals. What I mean is, I can write this formula as m1 into m2 is equals to minus 1, and I can plug in the value of m, the first m, that is 3 here, and I can find the value of m2. Or as you can see that m1 is multiplying here, and there it would be multiplied on the other side of the equals to, and it would be m2 is equals to minus 1 upon m1. So this seems like negative reciprocal. How? If I talk about this gradient, this is 3, and when I talk about the line which is perpendicular having a gradient of minus 1 over 3, we'll add a negative sign here and 1 over the first line gradient. So first line gradient is 3, so I can write here 1 over minus 1 over 3 as the perpendicular gradient of this line. And when I talk about this one, it would be placed here as well, and we can say that we can just switch over the numbers and we can change the sign. So this is 3, so we can write this is 3 over 1. If nothing is in the denominator, we can say that 3 is upon 1, and it has a positive sign. So we can have we can change the sign to negative, and we can make it reciprocate, that this is 3 over 1, so we can write 1 over 3 as the first gradient. And when I talk about this one, this has a negative sign. The negative sign and negative sign would be cancelled. It would be turned into a plus, because minus and minus is plus, and we can reciprocate this. So the 3 over 4 can be written as 4 over 3 in the gradient of the perpendicular line. So let's look at another question, that the coordinate of 4 points are O 0, 0, A 2, 3k, B 4k, 6, and C 10k, 7. And I need to find the value of k, whereas two conditions are given. So when I talk about the first condition, the point OAB are collinear, and when we talk about the collinear, that means it is lying on a straight line. When I talk about a straight line, that means they all will have a same gradient. If I calculate the gradient of OA or AB or OB, all of the gradient must be equal. So I can compare the gradients and I can find the value of k in this case. So I have found the gradient as of OA and OB, as 3k minus 0 over 2 minus 0. Let me recall you the formula. That gradient's formula is y2 minus y1 over x2 minus x1, and in this case I have taken these two coordinates O and A. So this is my x1 and y1, this is my x2 and y2, and I have plugged in the values to get the value of 3k over 2. And when I talk about the other one, the OB, I have taken these two coordinates B and O. So this is my x1 and x2, and this is my y1 and y2. This is x1 and y1, and this is x2 and y2. And we have plugged in the formula that y2 minus y1 over x2 minus x1, and we have got the fraction as 6 over 4k. So as they are the collinear ones, that means the gradient would be equal, and we can compare it that 3k over 2 is equals to 6 over 4k, and we can cross multiply it and we can get the answer as plus minus 1. This is plus minus 1 because when we multiply 3k by 4k, it would be 12k square, and 6 into 2 would be 12, then 12 would be here 12 would be divided by on that side, and it would get answer as 1, and this would be k squared. So we will take the square root and we'll have the answer as plus and minus both. And when we look at the other condition that OA is parallel to BC, so here I have again calculated the as gradient as OA, and the BC, then I have taken these two coordinates as for BC, gradient of BC, and when I talk about the gradient of OA, it remains exactly the same as I did earlier. So in this case they are saying that O is parallel to BC, and when we talk about the parallel lines, that means they are again equal. So I have again compared them, and I have just cross multiplied it and got the value of plus minus 1 over 3, done the same way as I did in part A. Let's look at one more question. The coordinate of the three points are A 1 comma 1, B minus 1 comma 4, C 6 comma K. Find the value of K if AB is perpendicular to BC. So my condition is now perpendicular. That means if I find the gradient of any 2 points like AB, the line AB, which is perpendicular to BC, so I will find the gradient of AB first, and I will use the formula of m1 into m2 is equals to minus 1, as I told you earlier, and I'll calculate the gradient of BC. Then I'll use any of the coordinate to find the k variable. So let's look at it. When we talk about the perpendicular concept, we have the formula as m1 into m2 is equals to minus 1. So first of all, I have found the gradient of AB using the coordinate of A and B. This is x1, y1, this is x2 and y2, and I have calculated as 3 over minus 2. And when I found the gradient of BC, it was k minus 4 over 7. So as the line is perpendicular to each other, I can place the value of m1 as 3 over minus 2, and m2 as k minus 4 over 7, and this equals to minus 1. So here it is, and I'll now solve it. So 3 would be multiplied by k and minus 4 both, and this 2 and 7 would be multiplied and then cross multiplication, and I got the answer as k is equals to 26 over 3 after resolving this. A last question, then we'll be up with for today's video. So this question is that we have been given a coordinate minus 2 comma 5, and we are given with the parallel line equation. When we have a parallel line equation, we can find the gradient from this line, and we can use this coordinate to find the equation of this minus 2 over 5 line. And when the other part, we talk about the other part, it has a perpendicular line given to us. So we'll look into both of the concepts. First of all, we have the equation of 3y plus 7x is equals to 29. I have noted this here, and I have make it a general equation, which is y is equals to mx plus c. So I have shifted this 7x over there on the other side of the equal to, so it is minus 7x. And when I multiply this 3y, so there it would be divided, and I want to have this y alone, because y is equals to mx plus c has y alone in it. So I have got the gradient as minus 7 over 3, And when I talk about the parallel lines, that means the gradient would be the gradient would remain the same of that parallel line, and I can use this coordinate to find the equation into after plugging it into the value of y is equals to mx plus c, and I'll get the value of first c, and then I can find the equation. So I have plugged in the value as y is 5, m is minus 7 over 3, x is minus 2, and I have resolved it to get c as 1 over 3, and I plug in the value of 7 minus 7 over 3 as m, and 1 over 3 as x. So I have got this equation. Although this is a correct equation, we can say that this equation is valid and it's good to go. But we usually write the equation in that term where there are no denominators in it. So giving the final answers, we can just take the LCM as 3, and we'll multiply it on the other side. It will get 3y is equals to minus 7x plus 1. So it is just a better way of representing the equation. We can write it like this, we can also write it like this, but this is the better way. So we write that way. Talking about the b part, I just noted down the equation, and I just just converted into y is equals to mx plus c, and here I have a gradient of 42 over 7. So this is my gradient after making it into a journal equation form. So the gradient is 42 over 7, and I talk about the perpendicular line. That means the negative reciprocal would be my gradient. I can say that if the gradient of this line is 42 over 7, so the gradient of my current line, which I need to calculate, is minus 7 over 42. So I reciprocated it, 7 would come up, 42 would come down, and here the plus sign, so I have placed minus sign here. And minus 1 over 6 were the coordinates given to me. So I will use this m and these coordinates to find first c, and then to find the gradient to find the equation, as I have told you in the previous case. And I can take again LCM as 6, and I can write it into this way: 6y is equals to minus x minus 37. So this is how we solve the equation of parallel and perpendicular line. Just the minor difference that parallel lines have the same gradient and perpendicular line have the negative reciprocate gradient to the other line. So that's all for today. Thank you everyone.